Hello and welcome to this Autodesk Masterclass on live animation binding. My name is Mark Jackson and I'm the lead technical supervisor here at Eurocom Entertainment. I run a team responsible for all the art pipelines across the company. That's all the Mayor and Max tool chains, everything from rigging, facial, animation tools, environments, asset support, exporters, etc. Currently supporting around 120 artists, animators and designers across the studio. I've put an outline up of what we're talking about today. We're talking animation binding and what animation binding is and how it relates to preset binder files. We'll be going through the advantages and applications. Why would you use this method in your production? What's it give you? Principles behind making a simple bind, that's the general outline. Different bind node scenarios, that's obviously within things like bipeds, there are various different systems that you have to treat slightly differently, and that's a brief outline of how we deal with those. And then making a full production binder, this will be taking you right the way from the start of the process all the way through to committing data back to your rig. So this is the whole mapping scenario, how to generate these things. And then driving a binder in production, there's various ways of actually passing source data to a binder, and that will give you an explanation of the different scenarios within that. And then finally we'll move on to some quite complex ideas. We've got a nice example of a quadruped which will give you an idea of how this can be expanded onto some really complicated mapping. Scalable skeletons is how we've traditionally dealt with characters of massive proportional differences, and that kind of leads on to Human IK, obviously with 2012, how you can integrate that into the systems as well to generate effectively a layered retargeting rig. And then finally, I've got a nice example of binding to raw optical data, just to show you how you can push this system, and it's quite flexible. You also get a UI that comes with this. This is just a tool set that I'll be using throughout this production, throughout this masterclass. I'm using it basically to speed this up, otherwise we'll be here all day. The instructions for installing, etc. will come with it. This is just a general outline, just to show you that what it is. So what is animation binding? It's basically a method of transferring animation data from one source onto your production rig. Now I use the word source very carefully there. This isn't limited to skeleton data. The source can be anything. As long as you can bind to it, it can be any data, as you'll see later on. And it's not a new technique. It's been used for many years for getting MoCap data onto custom rigs. The difference here is I want to show you how you can expand on this idea to allow for proportional remapping and taking data across characters that are completely different in their internal structures and proportions. And it's a very artist-friendly process. This isn't something that is all code-driven. This is something that is quite open and quite easy to understand, hopefully anyway. So it relies on a binder file. What is a binder file? The binder file is the preset mapping between your source data and your rig. So this is a file you've set up. It's an intermediate rig that explains how you map data from A to B. That's all it is. And it allows for proportional remapping on the fly. That's the big thing I want to get over here. It's also extremely customizable because it doesn't rely on rules. It's not one of these things. It's something that we used to do in code. So we used to have all our characters marked up. We know all our joints, we know all our controllers, and the code would run through the whole lot and automatically bind everything. And that's all very well and good if you stick with standard bipeds, but in production that doesn't happen. In production there is always something that you have to do that's different. So the character might all of a sudden have a tail, or he might have two heads that breaks your standard rules. So we decided quite early it was easier having an intermediate binder file that we could manually go away and tweak as we wanted. It just makes things a lot easier. And this is it. It's a very simple illustration, I admit. Over here on the right we have our animation rig. So these are all our animation controllers. This is our bind source. This is what's going to drive this rig. These are our bind nodes that are parented onto our bind source, and our controls of a rig are then bound up to these. And then we have our input data, which is going to drive our bind source, which is then going to drive our rig. So the area in blue is our bind file. This is what would save off as a bind file. And this is the input data we're going to plug into the bind source on that bind file. So what are the advantages? Why would we use a binder file? Well, it's very good at transferring animation data between different proportion characters and bridging that gap. It's extremely easy to remap libraries, so we've used it extensively in the past for passing animation data between characters where maybe there's a rig update that would normally break your animation pipelines, or if you're referencing, maybe it break your animations. And it's a nice way of bridging the gap between rig systems and new animation data, etc. We also use it extensively for loading our MoCap. So this is how we get MoCap onto our animation rig. We'd make a binder file and literally just drop the FBX file into this file, and we'd have our animation onto our rig. We can also link it, so we can link the input skeleton that we showed you. We can link that directly with another input, so we can have an animation rig driving another animation rig via a binder, and again we've got an example of that later on. And then expanding it into 2012, I've got an example of how we can layer this data, so how we can have that input data and use human IK to bridge the gap between some very different human proportions. Obviously this is because we're relying on a source driving a rig. There is only so far we can go within this. It's also very good at allowing offsets, so animating this and correcting your animation data between the performances is extremely easy. Because your rig is constrained to the input data via an offset node, we can key the offset node, and it makes things very, very easily for remapping data. So let's move on and show you some examples of this. Okay, so this is a nice example of some external binding. So what we've got here is 3 rigs that we've taken off the net. We've got our Andy rig, our Package Man, and Moon. And I kind of wanted to do this because I want to show you that there is no limitations. It's not like we're doing this to a preset rig. These are binders driving standard commercial rigs or standard external rigs. So if we look at Andy, what we've got is the rig, and then we've got a binder. So this is our bind source. This is a skeleton that's driving this Andy rig. And inside this, we've got our bind nodes. So if we just turn off polys or we turn on joints. So these blue ones, these are the skeletons inside the rigs. So that's Andy's skeleton and Package Man. And these red ones are the bind skeleton. This is what's actually driving it. And in actual fact, what's happening is that these yellow markers are the bind nodes. These are what are driving the controls on each one of these rigs. So if we turn that back on and we play the animation, you see we've got quite a nice mapping of the data across all 3 of these rigs. They're quite different rigs. Let's just play that again. And in actual fact, what's happening is that these are being driven themselves by another piece of animation data. So this is our master data. This is what's actually driving these. Remember me saying you can, to drive the bind, you can load an FBX or bind it to a skeleton. That's what's happening in this case. We're binding the skeleton up to these binder nodes, and this is then driving the Andy rig itself. And then the nice thing about this is it's live. So if I update this animation, all 3 of these rigs are going to take that new animation. So if we just load this one up, I'm going to drop a new FBX in. There's a few things you need to be aware of with FBX, which we'll cover later, to do with naming conventions and versions of the FBX, specifically with 2011. They changed some of the naming conventions, and like I say, we'll go through that. But we've just updated that FBX. It's updated this master source, and that's updated these binders, so we now have these 3 doing a different piece of animation. Nice little walk animation. Okay, so let's have a look at some of the other advantages. This is a nice one which kind of explains some of the advantages of keying. And just the nice way that we can change proportional mapping on the fly. So let's just open that one up. We've got 2 characters here. This guy here is on a binder, and this one on the right is on a rig. So this rig has already had the data baked to it. So this is animation on the rig. This one is a binder. And what we're going to do is we're going to adjust some of this animation. Now this is a really nasty piece of animation to adjust. So if we just play this thing out. I think this is running half speed, is it? Oh no, it's not. So we've got a really nice complicated piece of animation. And what's actually happened, let's say, is that the directors come in and they've said, well look, during this tuck here, what we need is we need to bend the knees a little bit more, and we want to tuck the arms in a bit more to it. So we'll go ahead and make those adjustments. Now, on the binder, what you're doing is you're adjusting the mapping, you're adjusting the actual characterization of this. So let's go ahead and do that. We go and we'll select these 2 rig nodes down the bottom. These are our feet adjusters, so these are our nodes for the feet. And I'm just going to go into Access Local. Right, so what we're actually going to do is we're going to put a 0 key at the start where we want to start the adjustment. And we'll put a key about there where we want to end the adjustment. All we're doing is saying that we're changing the animation data between these 2. In fact, we'll put a key just where it starts the tuck. There. Okay, so let's change the actual data. What we want to do is we want to bend his knees. So we'll just move this along. Drop a key, and what I'm going to do is I'm going to middle click and drag to kind of somewhere around here and drop the same key. All I'm doing is setting this as the same adjustment between the 2. And as you can see, this guy's holding that new shape all the way through. And in actual fact, what we're doing is we're not changing animation data, we're changing the binding, we're changing how we're proportionally mapping this data. Really nice and easily. Now let's do the same thing on this guy. This guy's on a rig. So this is rig data. So the first thing we're going to do is throw his animation into an animation layer. So we're going to select the 2 and we're going to set that into an animation layer. which gets rid of the keys. These keys are now in this layer, and we're going to adjust this on him layer here. So we'll do the same thing. We're going to start the adjustment somewhere around there. We'll set a 0 key, and we're going to end our adjustments somewhere around there, another 0 key. And we're going to start probably about there. Right, so let's adjust this. Remember when we came into this, we want to adjust where his feet go, so we'll move these two somewhere around there, drop a key. The problem now is that what you're actually doing is you're offsetting based on the animation that's going on already. So you're trying to adjust a really complicated spin rotate with keys. And what actually happens is that the correction you do there is nonsense for there, and actually you have to then go and move the correction. And as we come back round, again, that correction that you did to tuck him at that point is wrong for here. So you're always going through and you're trying to counter animate what's going on. Whereas the guy on the binder, you've put one key and you've said this is how we're changing the mapping. So it's really nice for that. Something else that's good with this is that if we go back to the start of these guys, in fact let's go to the end, is that because the binder is bound to every single controller, or rather every controller is bound to the bind nodes, we can go in and adjust really finely parts of the character. So for example, if we look at this pose, let's say that this back shape is actually wrong and somebody wants to go in and change this back shape. In fact, we'll go to X-ray. If I grab this bind node here, we'll go through why there's two in a minute. We go through and we'll just select the little diamond. Back to polys, go back to the X-ray off. And we just want to change this shape here. What we're actually doing is we're changing that single node. So you notice the shoulders don't move. Nothing else moves. The head moves obviously because it's being pulled by the spline IK. But effectively we're changing just the mapping on that. If we do the same with this guy, this is a standard rig. So if you adjust the shoulder, if you adjust the chest, the clavicles are going to go with it. And now you have to counter animate. So if you wanted to change the shape of this guy, you'd have to counter animate the hands and you have to counter animate the clavs. So that's another advantage of it. It's very good for shaping characters. And then finally, one nice thing about this is because these controllers are bound, now like a lot of rigs, we have a thing called parent switching on our rigs where we can change the parent space of this hand to pretty much anything that we want. But because this is bound up, we can do that on the fly and we can change this all the way through the animation without it actually affecting the animation. It only kicks in when you bake this data back. So you could choose, for example, during this whole tumble routine, that actually I want to be, I want the feet, for example, to be bound up to the hips. And then right at the end, when you come out of this, you could say, right, actually throw me back to the main controllers. So you can choose your parent switching on the fly, and it makes no difference for the actual data until you bake this out. So it's really nice for keying and adjustment. So let's make our first bind node and actually do some binding. Remember this file up. What we've got here is we've got the red skeleton is our bind source. This is what is going to drive our rig. And the rig is the blue. So the rig is the blue arm. And to start with, we're going to do a really simple one. We're going to go create locator. We're going to parent that locator under the forearm. Reset the transforms so it pops into place. That just puts it back in the position. And we're going to scale that up so we can see it. Notice I'm using the scales on the shape, not the scales on the transforms. It's always better to use these if you're doing locators. I'm just going to constrain our pole controller to it. And we're going to do the same for the wrist. So locator, select our wrist joint, parent it underneath there, reset the transforms, scale the thing up so you can see it, and constrain our wrist to it. And play the animation. So you can see it actually works, and it works quite well. There's our arm doing the bind. The problem is when you come to offset this data. If I were to grab this and overextend the arm, so we're changing the reach on the bind, for example. If I now come in and I just tweak that animation, what you notice is that the rotate is affecting the translate, and that's because that bind node is parented to the wrist, and that in effect is taking the translation data across as well. And that's no use. That's going to cause us problems. So we're going to take that one off, and we'll turn on this other example over here. In this one, all I've done is I've just scaled out the joints a little bit. This is just to give you a better idea of what's going on here. I've already done the pole vector here, and we're just going to do the wrist. So what I'm going to do is, again, I'm going to make myself a locator. I'm going to parent that under the wrist, parent, reset the transforms, scale it up so we can see it. And just open that up so we can see what's going on. Now, this I'm going to call transbind. And that's because this is going to be our isolated translation. And we're going to make another object. We'll make a cube in this case. Again, we're going to parent this under the wrist joint. Parent. Reset the transforms. Scale the thing up to see it. We'll just use those in this case. And now I'm going to rename that. This is going to be our rot bind. So this is going to be our rotation adjuster. I'm going to parent that underneath the transbind. Okay, so this is currently parented under the wrist. What I'm going to do is I'm going to parent it under the forearm now. And you'll notice that we get a translation pop in here. That's basically the length of this joint. And we don't want that, because what we want to be able to do when we're resetting the bind is select this, reset it, and have it locked to the joint that it's actually binding. So I'm going to freeze those off to get rid of them. And now I'm going to do a rotation constraint. So we're going to rotate constraint. We're going to take the rotate of the wrist, and we can constrain our transbind up to that. Constrain orientation. Now I'm going to lock those off. I'm going to lock them off so people don't key them, they don't mistakenly adjust them. And the same with the rotate, the one underneath it. This is just for rotates, and to make sure people realise that, we're going to hide all that out of the way. Lock and hide. And finally, we're going to constrain our wrist controller to this node. So constrain, parent constrain. And again, we get the animation still drives, as it should do. Let's just play it rather than scroll through it. But this time, if I select this controller and I move this along, obviously this has got a much longer arm than this, so what we might end up doing in production is just pulling that binder out there so that we get the same kind of motion going on. And you can see it works really well. And the reason it works well is, as I say, we've isolated our rotations and our translations for this node. So we can now adjust the rotations of this quite happily without it affecting. One other thing that we need to bear in mind is that for motions such as this, we've got a real straight line in this arm, and that's not giving our pole vector anything to work with. You often get cases like this where the pole will flip out or the arm will flip out, and the first thing we always do when we're making poles is just pull them backwards, and it just gives the RK system a bit more to work with. Now that's basically our two nodes. This is our simple bind node, this pole, because it's just doing a simple construction. This one we call our complex bind, which is just the two nodes. And if we open up the UI that comes with this class, there we go, there's the basic bind, which is this one, there's the complex bind, which is this one down here. We'll go through this more as we get on later in the class. Now something else we're going to do is we're going to set up some marker attributes on this. As you've been making these things, obviously we're going to put quite a few of these into a rig, and you want at some point to be able to find them all in the systems, select them all and bake the data out. And you want to make sure that you have a relationship between this. And I'm going to use message attributes, and message attributes are really nice because they're kind of blank attributes. They're just literally for passing messages between nodes and having a relationship between nodes. We use it extensively across the marking systems for the rigs, and they're really nice. And I'm just going to open our script editor up. We're going to do a little tiny bit of Python. We're going to do it in here primarily because when you come into the add atta, there is no way of adding a message attribute in here. These are just the standard types. And all we're going to do is import MasterClass as CMDS. That just imports the command engine. And we're going to go add attribute, CMDS list. So this is the currently selected object, the first index of the currently selected object, which will give me back what is actually currently selected. We're going to call it bound control, so that's the attribute we're going to make, and it's of type message. And we're going to add one onto there, onto that node there. And we'll also add one onto the bind node. And we'll call that BND node. Okay, so these two now have markers on them, and all I'm going to do is select that one. Select that one. We'll open up our hypershade. Still opening. There we go. In fact, I know you don't even need to do that. We'll just go through the connection editor. General connection editor. So we've got a transbind on the wrist, and all we're going to do is just take that and that, which are the two attributes we put on, and we're just going to make a link between the two. And what that basically means is that when you come into the hypershade, when it opens up, and we graph that, we've actually got a wire between the two. So there's our transbind, there's one. We've got this hidden wire, which has got the bind node up to the bind controller. Now what that means is that, again, in code, for a later date, we can find this controller and we can find the bind node that's actually controlling it, regardless of where it is in the scene. It's just this hidden message. It makes things really nice and neat. And that's what these controllers do. They run off those to be able to select the binds and select the controllers. Okay, so let's move on to the spine. The spine is quite a tricky one, really. It looks very similar to the arm setups, but there are a few things you need to be aware of when you're making it. So we've got a standard setup. We've got our bind source here, we've got our animation rig, and like most rigs, we have what we call fullback, which is just a cog. Basically, it's the parent of both our chest and our hip controller. So if I rotate that round, obviously it takes the entire back and spine systems with it. So what I'm going to do is I'm going to do the same as we did with the arm. I'm going to take the root source, so the pelvis, and our hip controller. I've launched the binder UI. This is obviously the one that we were talking about earlier on. I'm going to make a basic bind. I'm going to take the resets off because I don't want this hip to snap into place. I just want to leave it where it is and make the relationship. Basic bind. Now, our fullback has its root down here. So theory goes that you would take the root joint and the fullback, and we make another bind down there. And we're just going to do the chest area. And this is like the arm. This is a complex bind because you might want to extend it and resample animations. So I'm going to make a complex bind here. So that's our, let's just get this out of the way. So that's our basic spine. Now, that all looks to be good. The problem is that because we've bound both of these two controllers to our pelvis, the hips actually have no rotate. So if we were to bake this data off, there's no data on the hips because this is the parent of both of these two and we bound them both to the same node. So that's actually wrong. So what I'm going to do is the hip controller, I'm just going to delete that binder, sorry, and I'm going to use a point kind of somewhere up the spine, somewhere there. So I'm going to actually constrain this thing up to a bind node that's up here. And you'll see the difference of that in a second. So if we do that, we now have some of the data going to our cog, our fullback, sorry, and the hips actually have rotate data onto them. And often we'll build this and we'll see what's going on and we'll slip this data up or down the spine just to see where we actually get the best sample point from. And like the arm setup, we've got the ability here now to select this and tweak our offset positions and to tweak the rotates, etc. Let's do that there. So, you know, if you were trying to map two very different spines, you could tweak the binder and there's your bind. Now that all works really well when these two joints are kind of in the same position, or you know, the same sort of length. If I go to something like this one here, this actually hasn't happened that often in production here, primarily because we have the same kind of skeleton setups that we use throughout production. So you know, we don't tend to run into this very often, but it's something to be aware of. In fact, there is an example of this later on in the class with the quadruped spine. So on this guy here, I've done exactly what we've just done. We'll see this one has got more joints in the spine. His chest area is sampled from up here somewhere. This guy's got a really long chest, and it kind of doesn't make sense that you're sampling rotate data of this joint and passing it to a joint that's this far down. And you know, when we do things like that, it just makes no sense. So in situations like this, what we're going to do is we're going to use an aim constraint, and I'm going to do exactly the same as I've just done. So I'm going to select our pelvis and our hips bind. I'm going to select a node somewhere around there for our fullback. And what I want to do is I'm going to use the complex bind, which is the one that we made during the arm setup. I'm going to take these two check flags off on the UI. This is bind translates and bind rotates. If these two are off, you get the nodes, you get all of the message links, etc., but you don't actually get the controllers bound. So it's quite nice to build like an empty node that you can then tweak how you want. And I'm going to select these two nodes here. So I'm going to select a node just above where I want this thing to sit. So, and I'm just going to make an empty complex bind. And if you see, what's happened is that, as we did before, we've got our isolated translates, and underneath that we have our rotates. And as before, this translate actually has its orient constraint set already. So I'm just going to delete that, just to make sure this is just a blank node now. And then what I'm going to do is I'm going to make another locator, and I'm going to call this up vector. Call it whatever. I'm going to call it up vector so we know what's going on. And I'm going to parent it to this joint here. So we'll just parent it underneath that, just below the systems. Just below the systems. Parent, reset so it's in the right place, and we'll scale it up so we can see it, like we did with the rest of them. Okay, and I'm just going to move that back. And the reason I'm doing that is I want to give this up vector a solid, this aim constraint, we're going to make a solid up vector, so I'm going to sample it from this. I'm just going to take the name of that. Oops, excuse me, I didn't mean to move it. And I'm going to make the aim constraint. I'm going to aim it up to the neck. Now you could make another locator here, and you could aim it to the locator and have an offset. in this case I'm not going to bother. And like we did previously with the wrist, where we sample or rotate onto this isolated translate node, I'm going to do the same thing, but I'm going to use an aim constraint in this case. So constraint, aim. I'm going to aim the y-axis of the node, obviously because it's pointing up. I'm going to use the negative z for the up vector because the thing's pointing forwards and I don't want it to flip round. I want to point it towards this node that we've just made back here. And in fact it's already there. I'm going to use the up vector add. And what that's done is it's aimed this to point to the neck. And the only thing I'm going to do now is I've now got to pass the animation data, zero that off, over to our controller itself. So I'm going to use the rotate that we made before. So this is the rotate bind we made before, and I'm going to constrain our main shoulder controller to it using the parent constraint. Without we'll maintain offset. So I don't really want the thing to pop. And what we should now have is our data passed up. So what it's doing is, rather than sampling our animation data from this point, it's aiming up to the neck, which kind of makes more sense because you want the spine, you want the head generally to sit at the same position as it should do. There's always going to be scenarios where this thing can't quite reach because obviously they're two different spine-based systems and we have different joint lengths, so they can't quite target it. But if you compare the differences between those two, it's a lot tighter method of binding. And we've used this a number of times. Like I say, there's one in the quadruped example in a minute. So let's add some finishing touches to this. We've already gone through arms and spines and most of the systems. What I want to show you is just some finishing touches. Really, it's to show that there's no rules to this. All we want to do is drive something on our rig with a joint rotate or with a rotation of something else. In this case, it's the toe. Like most rigs, we've got a controller. This one's called toe wheel, as it happens, which is our toe tap, and we want to drive that channel with the rotations of this joints. Now at this stage I'm going to open up our bind UI. Now this is something that's going to come with this masterclass. It kind of sums up everything we've already done, and we're going to be using this in a minute to do a full production bind. All I'm going to do is I'm going to take these two off. These are the controls that actually make the connections. I don't want connections, but I do want to make the controller. So I'm going to select the joint that's driving, I'm going to select the controller, and I'm going to make the bind node, close that down, zero that off. And on top of that, I'm going to add onto this node a channel called toe multiplier. Now the reason for that is that the amount of rotate of this initial source joint might actually be different from what you need to drive your current rig, and it might be inverse, which happens quite a lot. So we're just going to go ahead and bind this thing up now with an expression. I'm going to do it as an expression purely because it's easy to look at. I could do it with connections, but it's easy to read if it's an expression. So the toe wiggle, which is our control channel, equals, I'm going to just copy that. I'm going to select our joint. Oops, excuse me. I'm going to select our joint, and it's the rotate X on our joint. Copy that. Equals that. Plus, copy that again. This node itself, this node has a rotate X. Copy that. So the toe controller, which is our toe tap, equals the toe rotate, which is our joint, which is feeding the data in, plus the bind, rotate X, so you can offset the rotation. And then we're going to multiply it by the channel that we put on this called toe multiplier. So toe multiplier. Correct. Okay, so now what happens is that if I set that rotate, our toe control should go with it. And it's not doing because I haven't set a value on that multiply by 1. Okay, so that's now driving it. So if we go back through this, we can see our toes nice and happy driving. And it gives you the ability to select this controller, and we can offset the rotates and how we're driving it. We can offset the multiply, how much actual data we want to send to that. So quite often happens that the rotate of this will be opposite, so we can invert it. So it's just a nice little finishing touch. Okay, so let's go ahead and actually make a full production rig here, a full production binder. First thing we need is our rig. So we'll load our rig in. And then we need the source that's going to drive this. So I'm going to drive it with this guy here. I've actually got some FBX data for this. So it's an FBX type driver. I'm going to deal with this namespace that's coming through the import. I'm just going to get rid of that. General namespace editor and delete that. And I'm going to call this something very obvious. So I'm going to call it bind source. just to make sure that we know this is the source of our binder, this is what's going to drive our rigs. A couple of things to note here. If you were running a reference pipeline and you were normally referencing your character rigs, this is the point at which you'd reference it. You'd have to reference it here. And the reason for that is that normally you would load your binder up, you would drive the binder, you'd then either bait the data back to your rig or leave it live, but then you'd save it out as your animation file, so you get left with the bind file. So obviously if you want to maintain referencing, you do it here. Something else to point out is that we use quite a specific prefix for anything that is FBX driven. And the reason for that is that FBX is node name based. So we have a root joint here, we have a spine, but we also, in the rig, we have a root joint and we also have a spine. So there's no guarantees that the FBX isn't going to mistake it and load it onto this guy. So by giving it an obvious prefix, we can guarantee that's where the FBX is going to load to. There's a few other things with the FBX I'll show you when I actually start loading FBX data into this. Something else I'm going to do is I'm just going to cut any animation data we've already got. So cut keys, select the root of that, below, cut the keys. So let's have a look what we've got here. We've got two characters here, and there is, there's quite a significant difference between these two. Obviously, this guy's a lot shorter. He's got slightly longer legs and slightly longer arms. Also, we've got clavs at the front on this guy, and clavs in the middle on this guy. It's the kind of differences that if you had an animation library using this skeleton and the rig was bound to this skeleton, you'd actually have quite a lot of problems in getting that animation data onto this rig. And this is the whole point. It bridges those gaps. So first thing we're going to do is we're going to scale this guy up. And we're only going to scale him up so general proportions of the characters are kind of similar. That's probably close enough. And then we're going to load up the kit. Again, this is the kit that comes with this masterclass. And we're going to go and make the binder. So we're going to start at the root. And we'll start at the root joint, the pelvis. And we're going to take this reset trans off. I don't want the spine to snap. I want it to stay where it is. And we're going to take the cog and we're going to kind of bind it halfway up the spine. This is again so we get animation propagating through to the hips. And then for the chest, we can use the complex bind. Again, this is so that it deals with offsetting a bit easier. And then we'll go through to the clavs. Now, the clavs in this case, there's an argument that maybe you should be using a name constraint here, and in quite a few situations we do, rather than using the rotate data. In this case, I'm just going to use rotate data. Incidentally, this bind trans, it's not actually going to make the bind trans in this case because we've got no translate channels open, so you don't actually have to worry too much about that. I'm going to make those. And let's go over to the other side and make the clavicle bind. And we'll start making the poles. I'm going to turn the resets on in this case because I want these guys to snap into place. It just kind of gets you further along the line. And we'll do the other one, we'll do the other arm, bind, select, bind, and the poles. No, we'll leave those on. No, we didn't do the head, let's do the head. Resets off. And then we'll move down the leg. So we'll start, oops, missed it. Complex, missed the resets, let's just undo that, turn the resets back on. The only reason for the resets is that, I mean, we could leave it like this and we could manually move these into place. It's just that it gets you a lot further along. And then we'll do the poles. Just turn the selectors off. Resets on, poles, resets on. And what have we missed? Nothing. That's it. So that's a basic bind. We've already done it. We've already done it. The first thing we're going to do, as we were talking about earlier, is we're just going to make sure our poles have actually been shifted out a bit. I'm just going to make sure I'm in world space, move those out. Again, this is just to give it more of a hint when you've got complex animations, to give more of a hint. And that kind of looks about right. So I'm going to save this guy. Actually, no, I'm not. I'm going to do one more thing. What I'm going to do is I'm going to make a character set. And I'm going to select the root of our bind source, of our skeleton. I'm going to use hierarchy below and create a character set. And we'll call that set, bind set. That'll do. Now let's save this out as our binder. Save scene, binder 4. Now obviously we've missed the toes. I could go in and make these toe joints, but they take a little longer, so we'll just take it for red that these are bound up. And let's have a look at some animation data. Let's actually load this up and start testing this. Normally it's a case of you would load an animation onto this, see how it reacts, see if you need to change some of the binding calibration. And by calibration all we're doing is literally just moving these along. For example, you might find in this case that it's better to move these hips down or better to move them up. You know, we're avoiding leg pop, etc. So let's load some data onto this. We're going to go File Import. That will do. A few things to bear in mind is that we've got the update here. We're using the update animation. Again, this is so that we specifically update the nodes themselves. We don't want anything else to come in with this. We just want to update the animation. Import. That will drop on. And let's have a look. So as initial bind, you can see that's actually pretty tight. That's not bad at all. There's a few things you might want to look out for. Things like leg pop over leg extensions, etc. normally are a case that the hips are in the wrong place. You need to just recalibrate those or shift those along. But as you can see, with doing very little work indeed, that's taken animation data over really nicely. Now, the reason we made this bind set is that if we go into the tracks editor now and we go create clip, what that's going to do is it's going to remove all the animation off this guy, off all the skeleton data, and it's going to throw it to the track. And what that actually means is that I can come in and I can drop in another FBX file and select the character set, drop that in. So that's 2 FBX files loaded, and I can keep doing that. So if you can imagine putting together a cutscene for this, for example, you've got multiple takes that you've made for a cutscene, and you want to verify which one you want to use, you can quite easily come in here and actually just drop them all in. And there we go, that's all those animations dropped in. So whatever he's doing, he goes running off and he disappears. And the reason he disappears is that one of the things with the tracks editor is that if you've got a single node as a root, by default what it'll do is it'll set the offsets. So it's actually set the offsets to be relative. And what that means is that when this clip finishes, the start position of his translate for the root joint will actually be where this guy ends. If I take those off, when this guy finishes, the other one will pop back to the start. Obviously that's our recording volume in the MoCap studio. So he pops back to the start of the recording volume and off he goes. If I put those back on, he will carry on running from where the other guy left off. And you can see that actually we stand a real good chance of putting an animation blend in there. And even if we didn't, what we could do is we could construct the animation files inside the tracks editor without blending, bake the data off onto the rigs, and then deal with the blending later. I actually think I could probably put a quick blend in between those two. So let's just have a very quick go at that. A few things with the tracks editor is if this guy were facing the opposite direction and you had to deal with the rotates, I wouldn't even attempt to blend. There's some limitations in the tracks, as everyone probably is more than aware of. In this case, I stand a real good chance, so I'm just going to put a quick blend in there. Blend, I'll shift it back because, and let's have a quick look at this. In fact, where do we end up? We end up with left foot down. There's left foot down on this guy. Left foot down is about there. So we're just going to foreshorten this clip a little bit. Oops. Grab it. I'm going to go foreshorten it a bit. Move it in. And what I'm going to do is also just going to change the type of this from quaternion short to linear. This will stop the hips rolling around as it's doing it. We've got quite a bit of travel in there, but you can see that actually. In fact, let's just wash that a bit. Where are we? There's one there somewhere. I know there is. Kind of. There we go. It's not too bad. Anyway, so you can see that we can quite easily construct files amongst the tracks editor for this, or at least use it for a preview. And then now we've got the character, we've got our animation on it, we've dealt with however we want to do, we've loaded in whatever animations we need to. We've got to figure out how we get this data off. Now, remember me when we first made this, we put a marker attribute on this. And the reason we put a marker attribute on is that I want to come into this rig and I want to actually find where all the controllers are, which controllers are bound, select the whole lot and run an anim bake on them. And we'll do the anim bake over, let's do it over this timeline we've currently got. And all that code is doing, in fact, if we open up the bind, which is this thing here, if I select the master node, this is our entry point to our rig, our internal production rig, and I go select bound controls, that will select all the controllers that are currently bound. And all it's doing is looking for that attribute. And literally all it is doing a list relatives of type, it's doing a list relatives. It's doing an attribute query for that bound control attribute that we put on it. If the node has that, it's selecting it, and that's ready for the bake. So all we're going to do is use this bake binder, which does all that, kind of wraps it all for you. So we'll bake the binder. That will then throw the data back to the animation rig, at which point we can ditch the binder from the scene. Okay, and ditch the binder. And what that leaves us with is our animated rig. And we can now save that out as our animation file. So it's converted the animation data from one character over to the other. Okay, so I wanted to move on to this file. This is quite a nice example. It's a typical production example around here. We have our binder that we've loaded up. This is our bind source, so this is a skeleton that's going to drive our new rig. And if we have a look inside this rig, we have some significant differences. The red skeleton is the bind source, so we have an animation library that's being driven by another rig externally, and this is the skeleton that's inside that animation. And the blue is the new rig. This is where we're trying to get the data onto. And like we did in the when we're showing you the spine, in this case I'm using an aim constraint because of these differences. You know, if we look down here, the spine is significantly different. In this case, we've got another bind node up here, which we're using as an aimer, and that means I can slip it up and down the spine to get a better adjustment. Tops of all these limbs, these are all also on aim constraints, basically because on this rig everything is free to move. And then down here we've got the tail that's bound up, we've got the jaw, and we could, if we wanted to, bind these ears up. But the main reason for this is I wanted to show you how to get data onto this without having to use FBX and without having to bake data to a skeleton. So what I'm going to do is I'm going to create a reference. And this is the animation library. We've got 3 animations. This could be, an entire library. I'm going to use a walk, and I'm going to create a namespace of driver. And the reason I'm referencing this in is because it doesn't bring any of the history into the file. All I want to do is sample animation data out of this, commit it to my rig, and get out of the file as quick as I can. So this is a typical thing that we would do, maybe in a batch mode, if we're casting lots of animations across. So if I just again turn polys off, you'll see that there's a skeleton. So this is a skeleton, which is the same as our bind source. And all I'm going to do is I'm going to bind these two together. If I open up our anim bind UI, in fact, we'll just do it through there because anim bind UI. And we'll put polys back on so we can see what we're doing. What I'm going to do is inside this, there's a skeleton. Sorry, this is the skeleton that is already animated. I'm going to bind our bind source skeleton to that, and I'm going to use this link skeleton hierarchies. Now, all that's going to do is it's going to do a list relatives of type joint underneath both of these nodes. It's going to do some name matching that gets over namespaces as well, and then it's going to directly connect the translates and rotates of the two together. So link. This is now popped into place, so the binder is now active and it's sampling data off that animation. You can see it's done really well. And now all I need to do is come into this rig. I'm going to select our controls. I'm going to use the bake binder like we did previously, which is again just selecting all the controls that have that marker node on them and baking the data. So that's committing the data to the rig. And then I'm going to go back into the reference editor, remove that file. Yes. Which leaves no history of that file back in there. Delete the bind source, and we're left with an animation on the new rig that's taken the data over nice and cleanly. So it's a really clean workflow doing it this way. So we've seen a production bind, we've gone through how to make a normal binder, but there are always scenarios where the character is significantly different enough for what we've just shown you to fail, particularly things like leg lengths, arm lengths, etc. If they are significantly different, we get into problems. And that's where this comes in. This is a setup we use, or we have used in the past. What we've got here is we've got our animated bind source, and then we've got this guy which is constrained up to it. All this is a skeleton that's been broken apart, so it's a broken hierarchy skeleton. There's our spine data, there's our arm data, and our leg data. And what it gives us the ability to do is, if I scale the legs down, if we've got a guy that's got really big torso but tiny small legs, this will still map. All it's doing is it's scaling the leg data down. Everything else is bolted onto the top of it. Now, you can quite easily imagine that if we were making a binder and we fed this to the binder, the FBX data would still load onto this guy, and the binder would manage the differences in the legs and the arms, etc. In fact, we can do quite a lot more with this. If we scale a guy up, we've got really tall legs, let's say. Let's focus on that. No, I can't focus on that. We've got things like we can scale the spine up, make him longer. We can select our arm adjusters. We can rehang our arms in positions. We can do things like change shoulder widths, change the collar widths, overscale the arms, etc. It's just a nice way of breaking the data apart and compensating for some horrible differences in characters. And it works really well. We've done all sorts like mapping human guys to guinea pigs and all sorts of strange scenarios. But it's a really nice way of getting over those problems that you just can't fight with on the normal production binds. So moving on from the scalable skeleton that we've just seen, I wanted to show you how we can incorporate human OK into the systems. It seemed kind of wrong with 2012 having human IK upgraded that we don't at least address human IK within this masterclass. So I've picked a character that's completely out of proportion. This guy's got a really long spine, short legs, short arms. It's the kind of thing that if you were using a normal binder that we've been working on, you'd run into problems, unless you had something like the stretchy skeleton that we've been using in the past. So what I'm going to do is I'm going to use human IK in this case to get this data mapped over. And the first thing I've done is, on this bind source itself, this is obviously a standard production bind, so there's our rig, there's our bind source. And this skeleton I've characterised in human IK. So we've opened the characterisation tool up, that's under here, characterisation tool. We've opened this up, and I've gone through each joint and I've set them up in the define here. So these, when it all turns green, that basically means we have a valid characterisation in human IK. And what that means is I can now create a control rig. I can create a human IK control rig on top of our bind source. So we've got our human IK controlling our bind source, which is controlling our rig via the binders. So we've got a layered binder. Now, what that means is that if I come in and I'm going to create a reference to a piece of animation that we've already got. And this guy's characterized too. So he's got a human IK characterization on him too, which you can see by, there he is just there. And if I send this guy to stance, if we go to the character controls, again, if we go to skeleton character controls are there, I'm going to select this guy, I'm going to send him to stance. Just to give you an idea of the kind of differences we're talking about here in the skeletons, that's quite a big difference. So I'm going to take him off stance, I'm going to select our anim bind source, which is the one we've just made a control rig for, and in the source you'll see that this new guy has shown up here. And if I click that on, human IK will then do the mapping for us. So human IK has now taken the differences between those two skeletons, those huge differences, and it's done the mapping. And it's done quite a good job for it. This obviously is only valid for bipeds. You'd run into difficulties if things fitted outside of the characterization. But it's a nice one to show you to get the differences over. One of the nice things about human IK is if we come into the edit properties on the remapper, we've got all sorts of things for example, matching source positions, which will make him travel the same distance as the source, regardless of things like leg reach. You've also got all the rest of the human IK abilities, like the floor, contact solving, and the reach and pulls, etc. But laid on top of that, you've also now got our standard binder. So, unlike human IK, what we can also do is we can, on the fly, very easily, drop a single key to offset all our animation data, or to correct it. So we've got human IK driving a bind source, the bind source driving a rig, and the ability to offset all of that live inside there. And then one last thing while we're on human IK, if we go back into that edit properties, one thing that's quite nice is there's a mirror animation node in there. So I can quite easily just send that over to the mirror and it will automatically mirror it for us. So that's quite a nice integration with human IK, something that we're probably going to be looking at more in the future. So I want to end on a really nice complicated file. This is raw optical data. So this is raw MoCap optical data, and we've been binding to this. So if I just play the animation through, and I just turn the skin off. This is our data. This is what we're actually going to try and attempt to bind to. Anyone that's dealt with MoCap data before will know there are no rotates on this. It's just translate data. It's just a point cloud. And the first thing we're going to need to do is figure out how we're going to extract a rotate, or how we're going to extract data from this point cloud. And if we turn on the bind sources, these nodes here are what we call stabilized nodes. And all a stabilized node is a wire that runs around a collection of points. Its position is constrained to the center of all of those. It has an aim constraint, and then it has a world up for that aim constraint so that things don't flip over. And in actual fact, they're actually quite easy to make. So let's go ahead and we'll make one for this head. First thing we do is we're going to make a curve. We're going to make it a one linear curve, just because we only want a single points. We don't want curvies. And we're going to reset these. So we're going to reset the world position of that one CV we just made. Finish the curve tool. I'm going to select those 5 markers, which are the head cradle. So that's the cradle that sits all the way around the top of our MoCap head. Select the curve, and I'm going to do a point constraint. Let's make sure there's no maintain offset. So that's now snapped into place. And now we're going to extract the rotation data. And what we're going to do is we're going to constrain this to the front of this. So we're going to aim it up to the front, and we're going to give it this side as a world up for that aim constraints, again, just to make sure that we extract it properly. So I'm just going to select that and select the name. copy that. So that one and our curve, constraint, aim constraint. I'm going to use the x-axis to aim because it's pointing forwards, and I'm going to use the I'm going to use the z-axis to constrain, pointing forwards. X-axis is the side to give it the up vector, and the up vector in fact is already there. I'm just going to object up, add. So that's now constrained up, and then all we're going to do is finish this curve off. We're just going to add a few more CVs in there. So I'm going to give an add tool, V, just to snap it, and we're going to snap it around this head cradle and then end. Now, one of the nice things about snapping it around is that if any of these things shift, you see it. If any of these markers actually slip during the MoCap, you see it shift. And we actually use this technique quite a lot, not so much to bind the character animation up, but we use this technique to bind up props. So things like guns or any other weapons or any other props that we might have to take through MoCap. MoCap team will generally give us the locators only, and the animation guys will make this. There is a button that I've got here, which the code for that is actually in the package as well, so I'll give anyone pointers to that if they need to. And as you can see, if I just scroll through that, that's taken our head data and it's nice and solid all the way through. Now looking at that, it doesn't take too much to imagine that you could take that and make a bind from it. So you could select that, select a head controller and make a bind. And that's exactly what we've done here. Oops, wrong one. That's exactly what we've done here. There's a head cradle that we already made. In fact, I'll just delete that. There's a head cradle that's already made. We've made one for the hips, one for the back, etc. And then we've made normal binds, as we've been showing you production bind. And that then carries the data all the way through. And in fact, if we turn on our character, there's our rig being driven by the optical, and there's our bound result of the rig. In actual fact, it's done a really good job. You can see it's maintaining the hip positions quite well. I haven't done any cleanup on here. This is just straight bind. Obviously, it's quite a difficult bind to get the positions right, etc. So I've done a little bit of tweaking in terms of calibrating the bind. But as you can see, it's quite a nice file to end on. And that's it. Thank you very much for watching. I wanted to leave you with a quick summary. Hopefully you found it useful. It's basically a very easy way of getting animation data across between sources and rigs. It's a nice way of passing data between differences in characters, and it's extremely easily batchable. Hopefully you saw within the quadruped example, it doesn't take much to write a batch that would process bulk files on this. We've quite often left our internal one running maybe 500 or 600 animations overnight to update systems in the pipeline. My email's there, it's markj3d@gmail.com. Feel free to drop me an email if you need to, or if you've got any questions. My blog's there also, and you'll probably find me on CD Talk or on Tech Artists. Thank you very much for watching.